Hello children, welcome to Zero Panic Maths. Let us continue our discussion on the relationship between the coefficients and the zeros of a polynomial. If you remember, in the last session we have discussed on the relationships of the coefficients and the zeros of a quadratic polynomial, and in this session we are going to continue and check whether the similar relationships will exist for the cubic polynomials also or not. Okay, now just to revise the things, what did we verified in the last session is if alpha and beta are the zeros of a quadratic polynomial, then alpha plus beta, that is the sum of zeros, then that will be always equal to minus b by a, which is actually the coefficient of x divided by coefficient of x square. Okay, and the product alpha into beta is always equal to c by a, which is constant term divided by the coefficient of x square. Now since we are dealing with a cubic polynomial here, we will have the highest degree of the polynomial as 3. Okay, so here it will be of the form ax cube. Okay, ax cube plus bx square plus cx plus d. Here there are 4 real numbers that represent the coefficients. Okay, actually 3 represent the coefficient and the fourth one d represents the constant term. Okay, we need to see whether the given zeros, here we are actually given with the zeros directly here. Okay, we are not going to resolve this cubic polynomial to get those zeros. We are already given with the zeros. We need to just find out the relationship between those given zeros and the coefficients a, b, c and d. Okay, okay, let us start that. Okay, now assume, okay, let us assume that since there are 3 zeros, it is a cubic polynomial, so obviously we are going to get at most 3 zeros. Okay, let us assume that alpha, beta and gamma are the 3 zeros of the given cubic polynomial. Okay, then alpha plus beta plus gamma, first thing that we need to observe is plus. Okay, the sum. Okay, let us sum up the values. For alpha, 4, considering 4 as alpha, minus 2 as beta and gamma as 1 by 2. Okay, consider that. 4 minus 2, I can directly take that as minus 2 plus 1 by 2. What is this? 4 minus 2 is 2. 2 plus half, that is 2 and half. 2 and half I can represent directly as 5 by 2. Fine. Okay. Now 5 by 2, since I need to represent this as in the form of minus b by a, just writing this as minus of minus just to represent this as minus b by a. Okay, so what is b here in this given? Okay, now let us write a, b, c, d first out of the cubic polynomial so that we can verify the values here. Okay, so what is the given cubic polynomial is 2x cube minus 5x square minus 14x plus 8. Fine. Okay, so what is a out of this? So just equating this with ax cube plus bx square plus cx plus d, a is 2, b is minus 5, c is minus 14, okay, and d is 8. Okay, now coming to this part. Okay, minus I've kept as it is, and what is minus 5? Minus 5 is b, correct? So that is b divided by what is 2? 2 is a. So The first part, that is sum of the zeros of a cubic polynomial, always represented by minus d by a. Okay. Okay, now let us continue with the product. Okay, product is alpha multiplied by beta multiplied by gamma. Okay, let me continue here only. Alpha multiplied by beta, or I can directly say alpha beta gamma. Alpha beta gamma is 4 multiplied by minus 2 multiplied by half. Okay, 4 multiplied by minus 2 multiplied by 1 by 2. So 2 and 2 get cancels. Minus 1 into 4, which is minus 4. Correct? Okay. Minus 4, I can say, I need to just equate that to d by a, minus d by a. Okay. I can just say this as, okay, let me continue considering minus 4 here and continue that product there. Okay. There's no space here. So alpha beta gamma is, what is the value I got, is minus 4. Okay, observe carefully here that how I'm converting minus 4 in the form of a d by a. So minus 4, I'm writing minus 8 by 2. It is actually minus 4 only, but I'm writing in the form of minus 8 by 2 because I want 8 to be equated to d. So what is this? Minus, I'm keeping as it is. And what is what is 8? That is d. And what is 2? It is the value of a. Okay. So what did we prove? That the product of the zeros of a cubic polynomial is equal to alpha beta gamma is equal to minus d by a. That is actually constant, minus of constant term divided by the coefficient of x cube. Okay, here what it is, minus of b is actually the minus of coefficient of x square divided by the coefficient of x cube. Coefficient of x cube in the denominator is fixed. Okay, so these are the two things that we proved. In addition to these two properties, we have one more additional property that exists for cubic polynomial, that is the sum and product together. Okay, what exactly it is? It is the sum of product of the zeros taken two at a time. Okay. Okay, now let us consider that also. Let us prove that also. Now what did I say? That it is the sum of product of the given zeros taken two at a time. The product taken two at a time. What is that exactly? Is alpha into beta, beta into gamma plus, okay, plus gamma into alpha. Okay, if alpha beta gamma are the zeros of a cubic polynomial, then the sum of products of the zeros taken two at a time, what does it gives us? Okay, so let us verify that. Okay, what is alpha? Alpha is 4. What is beta? Is minus 2. Okay, this is one product. Plus, what is beta? Minus 2. What is gamma? Is 1 by 2. Plus another product, gamma alpha. Okay, let me write it here. Gamma is half and alpha is 4. Okay, okay, now let us continue that. Minus 8. This is minus 8. 2 get cancels and plus minus 1 remains. Okay, and what remains here? It is 2. 2 2s are correct. So it remains with 2. Minus 8 minus 1, it is minus 9, plus 2 is minus 7. Okay, minus 7, can I write to represent it in the form of c by a? Can I write minus 7 as minus 14 by 2? Minus 7 as minus 14 by 2. It is minus 7 only. So what is minus 14? Minus 14 is our C. Okay, so this is C and 2 is A. Okay, so what is the additional property that exists for a cubic polynomial is, if alpha, beta, gamma are the three zeros of a cubic polynomial, then the sum of product of the zeros taken two at a time is equal to the coefficient of x divided by a. Okay, plus coefficient of x divided by a. So this is all about the three properties. So in generally we can say that if alpha, beta, gamma are the zeros of the cubic polynomial ax cubed plus bx square plus cx plus d, then the sum alpha plus beta plus gamma is minus of b by a, which is coefficient of x square divided by coefficient of x cube. Then the product, the second property, the product of the three given zeros is minus d by a, which is minus of constant term divided by the coefficient of x cube. Then the additional product, the sum of the product of alpha beta, beta gamma plus gamma alpha is always equal to c by a, that is coefficient of x divided by coefficient of x cube. Okay, now this is about the cubic polynomial. Okay, let us move to the next example. This problem is having two parts. Okay, the first part, they want us to verify that these three are the zeros of a cubic polynomial. First part, they want us to verify this. Okay, and the second part, then they want us to verify another thing, that whether the relationships that what we discussed in the previous slide, that the relationship between the coefficient and the given zeros, whether that exists or whether that is true for this cubic polynomial or not. Okay, now in the textbook itself they mentioned that this is not for examination. So if you want, you can take this as an example for homework. Okay, I'm actually going to give you the hint to this problem. I'm not going to solve this problem. We don't want to waste the time here. We will see some of the exercise problems in this session only. Okay, let us continue. Okay, now what is the equation? What is the polynomial? That is 3x cube minus 5x square minus 11x minus 3. I want 3 to be verified as whether it is a zero of a polynomial. Okay, so it is actually p of x. So to verify 3 as 0 of a polynomial, I will be putting 3 in place of x. Fine. Okay, 3 into x cube, that is 3 cube, minus 5 into 3 square, minus 11 into 3 minus 3. Okay, so 3 into what is 3 cube? It is 27 minus 5 into 9 minus 33 minus 3. Okay, so 27 threes are, it is 81 minus 45 minus 36, it is minus 33 minus 3, 36. So what exactly is this? It is 81. Okay, 81 minus 81, which actually got us 0. Similarly, you can try for minus 1, putting p of minus 1 and you will get 0. Minus 1 by 3 in place of x, you are going to get 0. So that is how you complete the first part of this equation. That is to verify whether the given zeros are exactly are going to satisfy that equation for 0 or not. The second thing is verify the relationship between the zeros and the coefficients. Okay, so let me give you one example, one part of that, as sum of the zeros, whether it comes to minus b by a or not. The remaining two you can verify yourself. Fine. Okay, so since this is the equation, what is a? Let me write the coefficient first. A is 3, b is minus 5, c is minus 11 and D is minus 3. Correct? Okay. Now, and what are the zeros? We are considering zeros as 3 minus 1 minus 1 by 3. Sum. Okay. Let us verify it for sum. Sum is 3 minus 1 minus 1 by 3. Fine. 3 minus 1, that is 2. 2 minus 1 by 3. Take the cross multiplication of this. 3 2s are 6 minus 1 divided by 3. What is that? That is 5 by 3. 5 by 3, can I write it as minus of minus 5 by 3? Because I want to prove it is equal to minus b by a. What is minus 5? That is minus b. Minus b. And what is 3? It is a. So it is true that the sum of the three zeros given for the given polynomial actually satisfies the condition that it is always minus b by a. So in a similar way, you need to prove it for the product alpha beta gamma, and the third one alpha beta plus beta gamma plus gamma alpha is equal to d by a, c by a. Okay, that you need to prove. So in the first part, you are left with verifying minus 1 and minus 1 by 3 are the zeros. By putting them into the cubic, you need to uh, arrive at the result that it is going to be 0. Then in the second part, you are left with the two things to be verified, that is alpha beta gamma leads to minus d by a, and then alpha, the third one. Okay, you need to prove that. Fine. Okay, now this is about the example 5. Okay, of course it is not going to be there for the examination, but you can do it as a practice. Okay. Okay, in the first set of exercise problems 2.2, we are asked to find out the two things again. We need to first find out the zeros of the given quadratic polynomial and then verify the relationship between the zeros and the coefficients. Okay, so there are two parts for each of the problems in this set of problems. Okay, first thing is solve this given quadratic polynomial and find out the zeros of the polynomial first. Okay, start with splitting the middle term. We have discussed this problem already, this kind of problems already. Split the middle term and factorize the given quadratic polynomial to find out the zeros of the polynomial first. Okay, now let us split this. Okay, now how do we split this? Okay, let me write this here. X square minus 2x minus 8. How are we going to split the middle term? Is it is 1 into x square minus 8, it is minus 8 x square and minus 2x. Okay, so we need to find out the two factors for the middle term such that the sum comes up to minus 2x and the product comes up to minus 8x square. Okay, what is that? That is 2 minus 4. I can say 2x and minus 4x. Okay, you see that 2x minus 4x comes up to minus 2x, and 2x into minus 4x will actually give us the product as minus 8x square. Okay, so let me write it here. Okay, let me continue here the splitting. X square minus, or x square plus 2x minus 4x minus 8. Okay, now what is common in the first two term? You remember the steps, right? Okay, I'm assuming that you remember the steps. So first term, I'm taking x as common. What is remaining? X plus 2. Right? Here, what is common? I can take minus 4 as common, so that I'm left with x plus 2 again. Okay, I'm not going to explain this because we have discussed such problems in the previous session. Okay, minus 4x minus 4 into 2, it is minus 8. So I'm again taking x plus 2 as common, so it will be x plus 2 and x minus 4 as the factors of this. So what are the zeros of this polynomial? So therefore I can say zeros of zeros, I can say, why to write the equation, zeros are, so if you equate x plus 2 is equal to 0, that will be equal to x is equal to minus 2, and if I equate x minus 4 is equal to 0, that will give me x is equal to 4. So what are the two zeros of the given polynomial? Is minus 2 and 4. Okay, now we are done with the first part of the problem, that is to find the zeros of the given polynomial. Now we need to prove that the relationship between the coefficients and the zeros that are found out that exist. So what is the equation? Equation is x square minus 2x minus 8. So I have a is equal to 1, b is equal to minus 2, and c is equal to minus 8. Right? Okay, now let us continue verification of the relationship. Sum is minus 2 plus 4. Minus 2 plus 4. That is 4 minus 2 actually. Okay, that is 2. Okay, now 2, can I write 2 as minus of minus 2 divided by 1? Right? It is minus of minus plus 2. So what is minus 2? It is b. So I'm keeping minus as it is, writing b, and what is a? That is 1. So the first proof is correct, that the sum of the zeros comes to minus b by a. Okay, now the second one, the product of zeros. Product of zeros should be, for a quadratic polynomial, should be c by a. Okay, so minus 2 into, sorry, 4, that is equal to minus 8. Minus 8, I can write it as minus 8 by 1. And what is minus 8? It is c. So c by a is 1. So this is how we proved the second part of this problem. Okay, let us quickly move to the next problem. Next problem is 4s square. Here the given quadratic polynomial is in terms of s, not x. Okay, so we are writing p of s here. Okay, we are writing p of s. Again continue the same thing. So we have 4s square into 1. So we have 4s square as the product to be, and minus 4s should be the sum. So I have 2 minus 2s. You can see that minus 2s, if you sum up, it comes up to minus 4s, and minus 2 minus 2, it is 4s into s square. So how I'm going to split the middle term is by minus 2s minus 2s. Okay, let us quickly do that. 4s square minus 2s minus 2s plus 1. So here what is as taken as a common? 2s, both in terms 2s can be common. So what remains inside? 2 common, 2 remains. S common, yes remains. So I'm taking 2s common, so it is 2s minus 1. So what is common between this? To make it as 2s minus 1, I'll take minus 1 as common. So it will remain with 2s minus 1 only. 2s minus 1. Fine. So again 2s minus 1, 2s minus 1, I will take it as common. Okay, 2s minus 1, and what remains inside? That is 2s minus 1. Here if you observe one important thing, that both the zeros are equal only. There are two zeros, but those are two equal zeros. So therefore zeros are 2s minus 1 is equal to 0. So what is s? S is equal to 1 by 2. For this factor also, it is 1 by 2. So 1 by 2 appearing twice as the two zeros of this given quadratic polynomial. Okay, now let us continue on the second part, that is to verify the relationship. Okay, so for that what we need is, first we need coefficients. So 4s square minus 4s plus 1, right? So what is a is 4. What is b is minus 4. What is c is 1. Now sum of the two zeros. Sum is half plus half. What is sum? Sum is half plus half. Okay. What is half plus half? It is 1. Okay. Now I just want to prove that this sum actually comes up to minus b by a. So I need to modify this 1 in such a way that it comes up to minus b by a. So plus 1, can I write minus of minus 4 divided by 4? You see what adjustment did I made? I'm keeping minus of minus, that is plus only. 4 by 4, that is 1 only. So there is no change in the equation, but I've modified that equation. So minus I will keep as it is. And what is minus 4? It is b. And what is what is 4 in the denominator? That is a. So that is how we proved that the sum of the two zeros that we found out for this equation actually is equating minus b by a. Now let us continue for the product of the zeros. Product is half multiplied by half, that is equal to 1 by 4. So we don't have to make any adjustment because 1 is already c and 4 is a. So this is how we proved that the product of zeros is always c by a. Okay, let us move quickly to the next problem. Okay, now the next problem is actually cx square minus 7x minus 3. Let me first write this equation here and write the coefficients so that we can verify it later. 6x square minus 7x minus 3. So by this way I have a is equal to 6, b is equal to minus 7 and c is equal to minus 3. Okay, let us keep that aside and go on solving the problem first here. Okay, now what is this? I have 6x square minus 3, that is minus 18x square, and what is middle term is minus 7x. So sum I should have as minus 7x, and multiplication, even if you leave the the variables, you can just look at the values also. Okay, so I can have the values as 2 and minus 9. Okay, 2 minus 9 is minus 7 and 2 into minus 9 is minus 18 x square. So we can split the middle term as plus 2x minus 9x to get the factors of this. Okay, I can just split that. 6x square plus 2x minus 9x minus 3. Okay, let us continue on taking the commons from the two terms. Okay, common from the first two term can be 2x. Okay, here if I am taking 2x in place of constant, it is 2 into 3, so 3 remains, and since I have taken x as common, x also remains. So 2x whole thing I have taken common, so it will be 3x plus 1. So I can take minus 3 as common and it will remain with 3x plus 1 here also. Okay, so minus 3 into 3x minus 3x minus 3 into plus 1, it comes up to this. Okay, 3x plus 1, 3x plus 1 taking common will give us 3x plus 1 as common, and what remains inside is the 2x and minus 3. 2x minus 3. Okay, so equating this to 0, 3x plus 1 is equal to 0 and 2x minus 3 is equal to 0 gives us the two zeros, and those two zeros are x is equal to, taking 1 to that side, that is minus 1, and x is equal to minus 1 by 3 as 1 0, okay, of this given polynomial, and minus 3 taking to that side 3, and x is equal to 2 taking that side 3 by 2. So the two zeros of the polynomial are minus 1 by 3 and 3 by 2. Now let us verify the sum and product of these two zeros. Okay, so start with sum. Okay, sum up. Minus 1 by 3 plus 3 by 2. Minus 1 by 3 plus 3 by 2. Okay, now sum up with the LCM. LCM has 6. Cross multiplication, it comes up to minus 2. 3 3s is 9. Okay, 9 minus 2, that is 7. 7 divided by 6. So 7, can I write 7 as minus of minus 7 just to equate it to the given values? Okay, what is minus 7 is b, so it is actually minus b, and what is a? A is 6. So sum is minus b by a, that is true. Okay, okay, now what remains is product. The same thing again, minus 1 by 3 multiplied by 3 by 2. So 3 here get cancels. What remains is minus 1 by 2. Okay, minus 1 by 2, I should be adjusting in such a way that it gives me c by a. So can I write minus 1 by 2 as minus 3 by 6? So 3 ones are 3 twos are, it actually gives me minus 1 by 2 only. So what is minus 3 is actually c, and what is 6 is a. So it is c by a. We have proved that also. It's that simple. Okay, let us move to the next problem. So this problem is little bit different because we are given with only two terms in this problem. Okay, there is no constant term given, so we don't have to actually split the middle term because we are already given with an equation from where we can get something common out of it and find out the zeros very easily. Okay, so 4u square, here the quadratic polynomial is in terms of u. Okay, observe this, 4u square and 8u. So can I write can I take the two common things from here is 4u. From here also I can take 4u. So if I take 4u as common, what is remained inside this? The first term u, 4u into u square. 4u into 2 actually gives me 8u, so it is u plus 2. So what are the two factors? The two factors are 4u is equal to 0 and u plus 2 is equal to 0. So when I equate 4u is equal to 0, I will get 1 0 as a 0 itself. Okay, and then when I equate u plus 2 is equal to 0, I'll get u another 0 as u is equal to minus 2. So what are the two zeros? 0 and minus 2. Let us verify the sum and product. Okay, so what is the equation given? 4u square plus 8u plus 0. I can write 0 as the constant term. Okay, so what is a? A is 4, b is 8, and c is 0. Okay, sum up. Sum is 0 minus 2. 0 minus 2. What is that? It is minus 2. Can I write minus 2 as minus 8 by 4? Minus 8 by 4, it actually gives me minus 2 only. 4 ones are 4 twos are. And what is I am keeping minus as it is, and what is 8 is B, what is 4 is A, so it is minus B by A. Now sum is correct. Now let us move to product. Product is 0 into minus 2, that is actually 0 only. 0 I can write 0 by 4, 0 by anything is 0 only. Okay, so what is 0 is C, and what is 4 is A, so I can say the product comes up to C by A also. Let us stop our discussion here only, and we will continue on the remaining problems in set 1 and the exercise 2.2, the second set of problems wherein we are given with zeros and we are asked to find out the polynomials itself. Okay, we will discuss that in the next session. Okay, thank you.